Dear students, welcome to video lecture session of DBMS. In this lecture video, we are going to discuss about database system concepts and architectures, the sub-concepts of DBMS. Subtopic is the database system environment. Here we are going to learn about the system utilities, database system utilities and tools, centralized and client-server architecture, classifications of DBMS. Lecture level learning outcome. Upon completion of this class, you will be able to analyze the features of database system environment and different tools involved in maintaining the database. And you can also explain various types of database system concepts using these tools, modules, and interfaces. And you will know the classifications of database helps in communication. Database system environment. The DBMS consists of several software components and interacts with several types of computer system softwares. DBMS component modules, database system utilities, tools, applications, environment, and communication facility. What are different DBMS component modules? The database and DBMS catalogs are usually stored in disk, as we know. Access to disk is controlled by operating system, which schedules disk input or output. A higher level stored data manager modules of the DBMS controls access to DBMS information that is stored on disk, both in database as well as catalog. DDL compiler. In the previous lecture video, we have discussed about data definition language, DML, DDL, TCL. Here, the DDL compiler processes the schema definitions specified in the data definition language and stores description of the schema, that is metadata, in the DBMS catalog. Metadata, we have discussed that data about data is called as metadata. A runtime database processor handles database access at runtime. It receives retrieval or update operations and carries them on the database. The query compiler handles high-level queries that are entered interactively. The pre-compiler extracts DML commands from an application program written in a host programming language. The DBMS system utilities. Most DBMS have database utilities that helps the database administrator in managing the database systems. Common utilities have the following types of functions. First one is loading, backup, and a database storage organization. What is loading? Loading utility is used to load existing data files such as text files or sequential files into the database. Backup. A backup utility creates backup copy of database, usually by dumping the entire database onto a tape. Database storage reorganization utility can be used to reorganize a database file into a different file organization to improve the performance. Performance monitoring, a utility to monitor database usage and to provide statics to the DBA. The statics is used by the DBA to make decisions such as whether or not to reorganize files to improve the performance. Tools, applications, environment, and communication facilities. There are tools often available to database designers, users, and database administrator. First one is case tools. Case tools are used in design phase of the database system. Data dictionary, or we can also call it as repository. It stores the information such as design description, usage standards, application programs, descriptions, and user information. Application development environments provides an environment for developing database applications and include facilities that helps in many phases of database system, including database design, GUI development, querying and updating, and application program development. Communication software. It allows users to remote location to access the database through computer terminals, workstations, or their personal computers. So integrated DBMS and data communication system is called as DBR, DC, data communication systems. And generally, it is often local area network is used to distribute DBMS physically over multiple machines. Centralized and client-server DBMS architecture. Centralized DBMS combines everything into single system, including DBMS software, hardware, application programs, and user interface processing software. And the user can still connect through a remote terminal. However, all processing is done at centralized site. This is a physical centralized architecture. Centralized architecture display monitors, that is end user display monitor, and it is a network, and all the terminals, application terminal, application programs, terminal to display text editors. This is all managed by your operating system. Basic two-tier client server architecture. Specialized server is specialized function, generally print server, file server, DBMS server, web server, email server. Generally, we have studied in operating system subject. And the clients can access the specialized servers as needed. So in this way, client and print server, this is, we can call it as two-tier client server architecture. Two-tier client server architecture. This is client and this is server, and it's a two-tier architecture. So generally, clients provides appropriate interface through a client software module to access and utilize the various server resources. Generally, whatever you are using, like for our case, CMS, course web page, these are the softwares, client softwares, which you are accessing it. Client may be diskless machines or PCs or workstations. With this, only the client software is installed and connected to the software via some form of network, either local area network or wide area network. DBMS server provides database query and transaction services to the clients, and the relational DBMS servers are often called SQL servers, query servers, or transaction service. Application running on client utilities and application API to access servers databases via standard interface such as ODBC or JDBC. ODBC connectivity, that is Open Database Connectivity Standard, and Java Programming Access, Java Database Connectivity for JDBC. This is to connect from front end to back end, that is application program to database server. We use these connections. The client and server must install appropriate client module and server module software of ODBC and JDBC. Two-tier client server architecture. A client program may connect it to several DBMS, several databases management systems, sometimes called as the data sources. In general, data sources can be files or other non-DBMS software that manages data. Other variations of clients are possible. Example, in some objects, DBMS more functionality is transferred to clients, including data dictionary functions, optimization, and recovery across multiple servers. Three-tier client server architecture. Common web application intermediate layer is called application server or web server, and it stores the web connectivity software and the business logic part of the application used to access the corresponding data from the database server. It acts like a conduit of for sending partially processed data between the database server and the client. Three-tier architecture can enhance the Security, database server only accessible via middle tier. Client cannot directly access the database server. In this way, it is more secure comparing to the two-tier architecture. So this is a example for three-tier architecture: client, application server, and database server. Classifications of DBMS data. There are several models to classify. Data model, and the data model is it's a relational model, and object model, object relational model, and big data systems like key value data model, document data model, graph data model, column data model, legacy data model. These are the different big data systems. And hierarchical data model, network data model. So relational data model, this is relational DBMS, and is where data is organized in two-dimensional tables using rows and columns. These tables are stored in separate file, and this RDBMS we are going to discuss in next chapter. And uses high-level query languages called SQL. Every table in database has key field which uniquely identify the each record. And the relational database management system is available personal computer workstations and large mainframes. Examples are Oracle Database, MySQL, and Microsoft SQL servers. This is an example for relational database model. Object data model defines data model in terms of objects, properties, and their operations. So relational database plus object database concept is equals to object relational or extended relational systems. And this classification of DBMS shape will be, this is a relation. This relation is called is a relation. Circle is a shape. Circle is a shape. Rectangle is a shape. Triangle is a shape. So this is generally it will be the relationship between the several entities. Object relational model is a combination of data model plus relational model, and one of the major goal of object relational data model is to close the gap between relational databases and the object oriented practices frequently used in programming languages like C, C++, Java, .NET. And this is the one. Hierarchical database, hierarchy starts from the root node and connects to all the child nodes to the parents, and it is used in industry on mainframe platforms. IBM and Windows registry is the example for that. And this will be the example of hierarchy model. College, department, and the department will have courses, teachers, and students. Courses will have different theory and lab courses. So this is a hierarchy. Network model. So network model database is a system where the data elements maintain one-to-one relationship and many-to-many relationships. So general example is this one. This is the network. College and teachers department, and teacher A can go to different departments. So this is network model. XML model has emerged the standard of exchange of data over the web and has been used as a basic for implementing several prototyping native XMLs. And it's like a hierarchical tree structure, and based on the number of user, criteria 2 is based on number of user. There are multiple user, single user systems and multi-user systems. Single user supports only one user at a time and mostly used with PCs. Multi-user system, which includes majority of DBMS, supports concurrent or multiple users. And the number 3 is categorized on number of sites. Centralized, distributed, homogeneous, and heterogeneous. Centralized. So DBMS is centralized if the data is stored in a single computer, and DBMS can support multiple users also when it is centralized. And its distributed DBMS can have actual database and DBMS software distributed over many sites. This is called as distributor, whatever you are using over now in the network, that is distributed DBMS. Homogeneous DBMS, the homogeneous DBMS distributed database, all the sites use identical DBMS and operating systems. There are two types of homogeneous. One is autonomous, which is independent, that function on its own, and non-autonomous data distributed across the homogeneous nodes and a central or master DBMS coordinates data updates according to the across the sites. And heterogeneous DBMS are two types again, federated, which heterogeneous database systems are independent in nature and integrated together. And unfederated, this system employs a central coordinating module through which the database are accessed. And based on cost also, it is divided. It is difficult to propose a classification of DBMS based on cost. We can also classify a DBMS on the basis of the type of access path option for storing files. So in this lecture video, we have seen the different utilities and tools and the centralized and client server architecture classifications of DBMS. Thank you.